Alrighty. Happy Wednesday, sports fans. We're here for an adventurous day of learning on polynomials. I know, you were gonna knock it out of the park today. So with our little snafu we had with the quizzes and everything else, we're spending like 2 days on polynomials. So that would be today and tomorrow, and then Friday we have always set up for you guys for like the review of the week, so that way you can get ready for your quiz on Monday. So Friday it's just going to be a review of P4, which we're doing today and tomorrow, and then your quiz is only going to be on P4, which is on polynomials. So take a little breather, I guess, for the week, huh? Sound snazzy to you guys? All right, perfect, beautiful, love it. All right. So P4 is polynomials. And we've seen polynomials throughout our mathematical career. And we look at terms and we look at degrees when it comes to polynomials. And just because, for the fun of it, what's the word poly mean? Anybody got any ideas? Multiple or many. Yep, exactly. So when it comes to our polynomials, a lot of times we have multiple or many terms. So if we think of a definition for our polynomials, it's ultimately it's terms or a sum of terms and sometimes our terms have variables and sometimes they don't have variables. So usually if it's a sum of terms, then on this one, if you're looking at sum of terms, you're going to have some variables in there. Because if you didn't have variables and it was just a whole bunch of things added together, you could simplify it. Right? So if we have a sum of terms, we're going to throw some x's or y's or ABCs or something in there. So let's think of a crazy one. Let's say we had, I don't know, 7x to the third minus 9x squared plus 13x plus 6. Those are some good numbers for today. So this is an example of a, hold on.
Please excuse the interruption. Freshmen and sophomores, voting for schools is now open today until 2 p.m. Freshmen, you are voting for class president. Sophomores, you are voting for class vice president. Directions on how to log in to voting for schools have been sent to your email account. The winners of both contests will be announced today by the end of the school day. Thank you so much. Have a great day.
You guys good with that? All right. So back to our polynomials. So a cute little example of a polynomial up here. When it comes to the word terms, terms are the parts that are separated. Easiest way to think of it is terms are separated with pluses or minuses. So this is one term. This is two terms. This is three terms. And this would be the fourth term. So for our example, you can, yeah, yep. We're just like, you're really just like counting the number of terms. So yeah. So like for our example, we have 4 terms. And the easiest way I remember them, they're separated by pluses or minuses. And just for like a little clarifying, like when we see the word sum, what do we think of? Addition, right? So is this really addition right here? Yeah, aren't you technically, I mean, if you really wanted to make everything addition, wouldn't this be like plus a negative 9x to the squared? Right? So even though it has a minus sign there, it's technically still a sum because you can add it as a negative. Does that work? And then the other way we classify our polynomials are by the degree. So your degree is when you're looking at your exponents and you're looking for your highest exponent. So like this has got an exponent of 1. This one's got an exponent of 2. This one has an exponent of 3. Yep. So this would be a third degree polynomial. So you're looking for that highest exponent. So it helps if we put these in what we call standard form. And standard form is just when you're looking at your variables and you're putting them from highest degree down to lowest degree. Right? Makes it kind of easier when it comes to that third degree is telling us that it's a third degree. It's telling us that we have possibly 3 solutions if this was equal to something. It tells us how many turning points we have if we want to graph it. So it's easier if we put it in that highest to lowest, so that way we can like, boop, there it is. Right? Boop, there it is. Boop. All right, never mind. All right. So today we're just going to kind of look at adding and subtracting some of these polynomials. Oh wait, can't go yet. Forgot. So then we classify our polynomials when it comes to these number of terms. There's just a couple, 3 of them that we're going to go over. So if I gave you 2x squared, how many terms do you think that has? Yep. So that has 1 term. So that's called a monomial. Because mono means 1. Good job. And for poops and giggles, what's our degree? So is this a second degree polynomial? Right. What if we had 3x plus 2? How many terms does that one have? 2 terms, yeah, good job. Anybody want to guess what a 2-term polynomial is called? Binomial, yep. Because bi means 2. Good job. And for the fun of it, just on this problem, not all binomials, but just this binomial, what's the degree of this binomial? 1. Yep. And then what if we had 6x to the 4th plus 2x squared plus 5? How many terms does that dog have? 3 terms. And a 3-term polynomial is called a trinomial. Whoop. Because tri means 3, right? Did you guys ride your tricycle to bike today? And for the fun of it, what's the degree of this polynomial? 4. Yep. All right. Now let's just do a little adding and subtracting. So let's start off with a nice little addition. So I'm going to start off with this polynomial, and I'm just going to throw it in parentheses. And I'm going to go with negative 9x to the third plus 7x squared minus 5x plus 3. Is that a polynomial? Yep. How many terms? 4. What's the degree? 3. Good job. And I'm going to add to that another polynomial. I'm going to go with 13x to the third plus 2x squared minus 8x minus 6. That one's a polynomial. That one still has 4 terms, and it's got degree 3, right? So ultimately, when it comes to adding and subtracting polynomials, you're combining like terms. And we know we have 4 terms. So again, our first term with our x to the third, we're just going to combine that with any other x to the thirds that we have. We got this little guy over here. When it comes to adding these and how you want to set it up or how your mind works to add them, it's kind of like your personal choice of where you are with your mathematics. Some people can just sit there and go negative 9 plus 13 and be able to write it down. Some people need to write the whole thing out. So you would have like negative 9x to the third plus 13x to the third. And then going to your squares, plus 7x squared plus 2x squared, going to x, minus 5x minus 8x plus 3 minus 6. Some people, it's easier if they write it out that way, and so that your terms are right next to each other. It's kind of a personal preference of wherever you are to be able to do these. So how many x to the thirds do we have? You had negative 9x to the thirds, and you got 13x to the thirds, so we have a total of 4x to the thirds. How many x squareds? Yep, 9x squared. How many x's? Negative 13. And how many whole numbers? Negative 3. All right. So what if we wanted to move on to doing some subtraction problems? So let's say we had 7x to the third minus 8x squared plus 9x minus 6. And now I want to subtract another polynomial. I'll move that up for you guys. And let's say the other polynomial, 2x to the third minus 6x squared minus 3x plus 9. So in my ancient years of experience, when it comes to us adding polynomials, we usually do a pretty good job of making sure we don't screw up our signs, and we know that we're adding, so we're good to go. When it comes to subtracting polynomials, this is where we sometimes think too fast maybe, and we get ahead of ourselves. Because when we are subtracting, like you're subtracting each one of these terms, right? So sometimes we just kind of get in a hurry and we're doing, I don't know, like if you were doing the x's, you read it as 9x minus 3x. And we're not doing min x minus 3x, right? That would be like adding them together. We're subtracting it. So it's technically 9x minus a negative 3x. So different people do it different ways. Some people go ahead and go through and they distribute that negative through everything. So they make this a negative, make this a positive, make this a positive, and make that a negative, right? And they just write it right in there. Some people write the whole entire thing out, kind of like how we did up here. So that way they're making sure they're taking the negative to everything. And then some people just kind of go, I can go from 7x to the third minus 2x, and they can go each way. So it's all personal choice on how you guys want to do the problem. So let's see if we can kind of do it all mentally in our head, right, without writing down all the other steps or putting in the pluses or minus. See how we do. How many x to the thirds do we have? 5. How many x squareds do we have? Yeah, -2. Good job. How many x's? How many? 12? Yep. Good job. And how many whole numbers? -15. Everybody good on where all those numbers came from? Pinky swear? All right. Think you guys are good to go? Need to do any more examples?